Hi there. Today I'd like to talk about this use of the scientific method in evaluation. Most especially, I want to talk about the use of very quantitative methods, most of them in the range of experimental methods. What an experimental method is that you take a population of things, say it's got 100,000 things in it, and you go to that population, you got a list of everybody, and you randomly choose every 20th person, or you randomly pick numbers using a random number generator. And you take this group of things and you put them over here and you call them the experimental group. Then you take another 300 or 600 or however many you can get, and you put them over here and you call them the control group. The experimental group, you give some kind of a treatment. If they're paramecia, maybe you'll increase the salinity of the water they're in. If they're human beings, maybe you will put the experimental group through an educational program that you withhold from the control group. But somehow you give them different treatments. And then at the end of the process, you go in and you measure the differences between the experimental and the control group, and the differences between them will tell you whether the treatment caused a change or not. There's also quasi-experimental methodology, which is used more in the social and human sciences, in which you administer the treatment out there under natural conditions. And then when the time comes to evaluate, you match the places where the intervention was implemented to places where it was not implemented, or to units that did not receive it. And you measure the differences. And you assume that the experimental group, that the people that got the intervention, are not systematically different from the control group. So usually in a quasi-experiment, you'll match the controls on if they're people, region of the country, gender mix, age mix, things that will help you to narrow them down so that they're a comparable population. These kinds of methods have always been and are still very prominent in evaluation. Part of this is because evaluation has its roots in education, which historically has been leans quite a bit toward experimental and quasi-experimental evaluations of curriculum interventions or classes or special programs. You will find many people who think that experimentation and quasi-experimentation are the only valid way to do evaluation. I sincerely hope that is not true. And I don't believe it is. But you must understand these methods as well as possible, because otherwise you won't be able to communicate with your colleagues, and there's a whole bunch of evaluation and debates within evaluation that you won't understand. The big question that lies behind this debate is one of the locus of truth. Is there truth outside there? Is the truth inside of people, and we judge it by their perceptions of it? Is there no such thing as truth, so that everything is completely relative? The positivist sciences and others, I don't know how wide a brush I want to use with positivism, but others who use these kinds of experimental methods assume that reality is out there, that there is a reality that can be known. And over the course of many experiments, the scientists will begin to converge on an ever more accurate picture of that reality out there. Although philosophically, we'll never get there. If you assume that there is a single reality out there that is true, would be the same for all observers, then your approach to understanding that reality assumes that it's the same for all observers, and the fact that it looks different comes from errors in human observation. And if you can set up the experiment in such a way that all of the errors of human observation are removed, then you can begin to converge on this substantive truth out there. This is the time-honored scientific method. The experimental method was first used certainly in the Enlightenment by all of the naturalists and the emerging chemists and physicists who built the scientific world that we know today. Many of these measurements, or many of these experiments, were laboratory experiments. Now, laboratory experiments are kind of nifty because in a laboratory experiment, you can control a lot more of the outside parameters than you can in a human experiment. So if, for example, you want to discover the motility response of paramecia to different saline levels, you can control the temperature in the laboratory, can control the ventilation, you can control the amount of light, you can control lots of parameters of the environment in which your experiment is conducted. And then you have 4 or 5 tanks, and you vary the saline level from one tank to the other, and you let the paramecia grow for a while, and you take them out, and then you measure how fast they move. And you know now pretty closely what the relationship is between paramecium speed and salinity of the water. By the way, I don't know that there's any relation. I just made that one up. The goal of experimentation is to remove the human factor as much as you possibly can. So you want to set up your observation in the most value-free way possible. Measure your observations also in a value-free way using instruments that have been well tested on lots of populations, what are called validated instruments. And then when you get your measurements, you compare them and you assume that the differences that you observe are made up of 2 factors: observational error, which is that human thing that is hard to get rid of, and the true effects of the phenomenon you're looking at. And if any of you have ever done regression analysis, you'll recall that there is a line through a whole bunch of data points, and then there's a zone that is assumed to be random variation. Then there's a great big zone that is error. The error zone, the part that is called error, is that human observation thing. So, moving right along here. Experimental and quasi-experimental methods are often used in social situations. Doing that is problematic in a lot of ways. And we'll be exploring some of these as the semester goes on. However, the problem on the face of it is that human beings, especially human beings living in interaction with other human beings, are a lot more complex than paramecia. And the error terms that affect human beings acting in company with other human beings are legion. I mean, there are just a lot of error terms. You never get even reasonable control of the error in doing experiments in social science. For 25 years, I was married to a physicist. And one of the things that we had to straighten out early in our intellectual relationship was an understanding of the different standards we had for truth in scientific investigation. For him, if there was a probability of more than 1% that the observation was random, you had to throw it out. They have very high standards for measuring error because the phenomena they look at don't vary all that much. For me, if I could set up an experiment that explained 30% of the variation, I felt great. If I could even get 15% of the variation in a human experiment, I felt pretty good about my work. That's the difference. The other problem, of course, is that experimentation can only tell you what the differences are, as measured using some kind of an instrument. They can never tell you why. So you can get good correlations. You can develop hypotheses about causality, but you can't. It's very hard to infer causality in an experiment because you don't know the links between what you're observing. Also, getting correct measurement is a big deal. There's tremendous concern with the accuracy of instrumentation, whether the instrumentation is measuring the same thing in different people. So psychologists in particular spend a great deal of time working with instrumentation, testing instrumentation, trying to make sure that it performs in a similar way across a wide variety of conditions. So as we'll see as we go on in this course, evaluation is a lot more subtle than is implied in experimental methods. This does not mean that they're not good. Experimental evaluations are very convincing because they have good, solid measurement of how much of something there is. And very often, that's what clients want to see. More often, however, they ask themselves the question of why did this thing show up the way it did, particularly if the results are counterintuitive. And that's where we come in. So as we'll see in subsequent weeks, there are many other methods, a lot of them native to anthropology, which will allow us to demonstrate the what and also get some estimate of the why. And very often we work in interdisciplinary contexts where we combine these methods. And of course, experimental methods combined with other methods are very, very convincing because they not only give you the what and how much, but they explain why you're observing what you are. So that's it for this time. Talk to you next time. Bye-bye.